last basic derivative rule, that is chain rule. Take note the derivative of f of g of x. So this means we're given a composite function. So in other words, chain rule is used if we are given a composite function. A composite function is a function that is combined by two or more functions. In this example, if we are asked to find the derivative of f of g of x, so all we have to do is to remember this formula, which is equal to f prime of g of x, which is actually the derivative of f of g of x times g prime of x, where g prime of x is the derivative of g of x. Take note the g prime of x is the derivative of a function that is inside to another function, let's say f. So to understand more on chain rule, we have an example. Okay, example. Our example is let f of f of g of x be equal to quantity of 2x cubed minus 5x squared plus 4 raised to 10. As you can see, this is a function. Why? Because we can let our f of x to be x raised to 10 and our g of x be equal to a function that is inside this function x raised to 10. Let's say 2x cubed minus 5x squared plus 4. So this is a composite function. Now, since this is a composite function, so we can use chain rule. So in the chain rule, what is needed is f prime of g of x and g prime of x. So all we have to do is to let our g of x. What is our g of x? Is the function that is in the innermost of another function. So in this case, our g of x is equal to 2x cubed minus 5x squared plus 4. Okay? Now, if we already identified our g of x, so this time we are going to find the g prime of x. What is g prime of x? G prime of x is the derivative of g of x with respect to x, which is equal to 6x squared using the power rule minus 10x, again, the power rule. Then the derivative of 4 is constant, is 0. So therefore, this is our g prime of x. And what is f prime of g of x? So f prime of g of x is actually the derivative of this. So the derivative of this, we consider this as one variable, for example. So we have a variable raised to 10, right? Then using power rule, we come up with the derivative of f prime of g of x, which is equal to 10 times this 2x cubed minus 5x squared plus 4 raised to 10 minus 1, which is equal to 9. So this is actually the derivative of f of g of x. So we already have g prime of x and f prime of g of x. So we are now ready to plug in this formula to the formula that we have. Okay? So using the formula above, we have derivative of f of g of x is equal to f prime of g of x, which is this one, times g prime of x, which is this one. So we have quantity of 6x squared minus 10x. So this is our final answer. So this is the derivative of the composite function given earlier. Now, some of us prefer to use minimal number of variables. So they resort to change the variable instead of x or instead of g of x. They have this changing variable process. So the derivative of f of g of x, this is the original formula for a composite function. This can be written also as the derivative of f of u. F of u, where u is equal to g of x, right? Because this is f, right? And if you're going to substitute g of x by u, then this becomes derivative of f of u. So if we're going to look at this one, this is simpler compared to this original function. Because some of us prefer to have a simpler function compared to quite complicated function. That's why they resort to change variable. So if this is now our formula, then the derivative of f of u becomes what? Becomes this one. So if we are asked to find the derivative of f of u, and take note f of u, where u is a function of g of x, and we're asked to find the derivative with respect to x, not with respect to u. So this is equal to f prime of u. So all we have to do is to find the derivative of f of u first, then times the derivative of u with respect to x. Here, f is a function of u and u is a function of x. To understand more, let's go back to our first example. So the original example is let f of g of x is equal to the quantity of 2x cubed minus 5x squared plus 4 raised to 10. Now, we can use this formula instead of g of x. We can let our g of x, which is the function inside, to be our u. So we let u is equal to 2x cubed minus 5x squared plus 4. Then after this is we're going to find the derivative of u with respect to x with the use of this notation du dx, which means the derivative of u with respect to x. Now what is the derivative of this with respect to x? This is 3 times 2 is 6. X raised to 3 minus 1, we have 6x squared minus the derivative of 5x squared is 10x. The derivative of 4 is constant, so it's 0. So therefore, we have du dx, which is equal to 6x squared minus 10x. Okay? Now, what is our f of u? Our f of u is a function of u. And since this is our u, take note, this is our u, so our f of g of x becomes f of u. So since this is our u, therefore f of u becomes u raised to 10 because this is our u. Okay? Now, what is f prime of u? The f prime of u is the derivative of u, which is equal to 10 times u raised to 9 by power rule. This is actually the derivative of u raised to 10. Applying the power rule, 10 times u raised to 9. Okay? So to finally answer the problem, to find the derivative of f of u now, we use this formula. We already have the f prime of u and the du dx, right? So what is our f prime of u? This is 10u raised to 10 minus 1 times du dx. Now, the original problem is in terms of x, right? So all we have to do is to substitute our original value of u in this u. So since our u is in terms of x, this is our u. So all we have to do is to write that original function in replacement of our u. So 10 times quantity of 2x cubed minus 5x squared plus 4 raised to 9, because this is our u, and our du dx. What is our du dx? 6x squared minus 10x. Again, so we were able to compare our first method and the second method using different types of variables. But again, we come up with different answer. So it's up to you what method or what variable that you are going to use, and you have to use the most convenient to use for you. Okay, so that's it. Now, for the second example, to really understand on the topic, because chain rule is quite complicated as compared to the previous examples that we have. So in this example, we are asked to find the derivative of this expression, that is the quantity of 2x plus 1 over 3x minus 1 raised to 4. Can we use chain rule here? Yes, we can use chain rule because we have a function of another function. So we can let this one to be another function that is inside to a power function, right? It's quite obvious in this example. So I will use the second method just to simplify the formula. So we let f of g of x be equal to the quantity of 2x plus 1 over 3x minus 1 raised to 4. Now, I, I rather use this u instead of g of x. So we let u, the function inside, which is equal to 2x plus 1 over 3x minus 1. Then, our f of u is equal to what? If this is our u, we have our f of u, which is equal to u raised to 4. Thus, the derivative of f of u, this is dx, okay? This is dx, is equal to f prime of u times du dx, okay? Because we are getting the derivative with respect to x. Okay, now, what is our f prime of u? If we have f of u, which is equal to u raised to 4, then f prime of u is the derivative of f of u, which is equal to 4 times u cubed, then times du dx. So all we have to do is to find the derivative of u with respect to x here. So we solve first the du dx. So what is du dx? Okay, the du dx is can be obtained by getting the derivative of 2x plus 1 over 3x minus 1. As you can see here, by the way, we already substituted because we have 4u cubed and our u is 2x plus 1 over 3x minus 1. So we have 4u cubed times du dx, which is the derivative of this. Okay? Now, the derivative of this can be obtained by using quotient rule because this is quotient of two expressions. So this will be copied and use quotient rule. We have 3x minus 1, you square this one, then copy 3x minus 1, which is the expression in the denominator, times the derivative of the numerator, which is 2, minus the numerator times the derivative of the denominator, which is 3. Then simplifying the expression, we have 3x times 2, which is 6x, negative 1 times 2 minus 2. 2x times 3 is 6x times negative minus 6x. 3 times 1 is 3 times the negative sign, which is negative 3. Then simplifying the whole expression, we have 6x minus 6x, this will be 0, minus 2 minus 3, then we have negative 5 over this expression. As you can see, 4 and negative 5, these are constants, so we can multiply this one. 4 times negative 5, we have negative 20. Now, since this whole expression is raised to 3, this means 2x plus 1, or quantity 2x plus 1 raised to 3, and quantity 3x minus 1 raised to 3. So in other words, we have negative 20 times 2x plus 1 raised to 3. Now, since we have the same denominator and we have the exponent of this denominator is raised to 3, so all we have to do is to add the exponent. We have 3 and we have 2, so we come up with quantity of 3x minus 1 raised to 5. So this is now our final answer. This is the derivative of the given function earlier. As you can see, it's quite complicated, but still we come up with the simplest form of our answer. So this is how we use and how we apply the chain rule. Okay, hope you like this video and hope you learn from this video, and I suggest that you keep on sharing what you have learned from this video. Thank you and God bless.